Oh, hi everyone. Thank you for showing up for your learning. Uh, yeah, so I'm not there again because these are crazy times we still live in. But I wanted to go over the review sheet that I created for you because many of you will have questions, and this is as good a place as any to talk about those questions. All right, so let's take a look. Our first question types have to do with identifying is that thing a function or not, and then stating the domain and range. So when we're looking at is it a function, we're going to take a vertical line and drag it across these things. So here I can see that a vertical line would touch this at only one point. The first one, A, so it is a function. B, on the other hand, wow, that vertical line, even the y-axis itself is touching that at 3 points, so it is not a function. This one here, when they're in a table or we're looking at a collection of points or a mapping diagram, we want to look at whether any inputs have multiple outputs. So I see -1 maps directly to 0, 0 maps to 1, 1 maps to both 3, and 5, not a function. Okay, so whenever you see an input having more than one output, then it's not a function. Notice that we don't care if two different inputs produce the same output. Okay, like it's not the horizontal line test. This is no problem. This is still a function because for any one input, there's a unique output. For this input here, 2, there's only one output. Okay, and that would be like about -1 or something. If I input 4, then I output like 2.5 or something like that. So all those are fine. Those all satisfy vertical line test. That's why that's a function. If you were to graph these points down here, this would violate vertical line test. Looks better. Now, what about identifying whether this equation is a function or not? Well, the general rule for equations is that if your y is raised to the power 1, or it's not being raised to a power other than 1, then yes, it's a function. So this one, yeah, it's a function. But I'm testing you here. Can you look at that and recognize that that's a quadratic? Recognize that that's a quadratic in vertex form. I create a sketch so that I can visualize this. These coordinates give me the vertex, and this one tells me the stretch factor. So it has a vertex at 2, -5, and as a stretch factor 3. Wee, it's growing. Wee, it's growing. And it doesn't squiggle. I don't know why that squiggled there. So anyway, now let's talk about domain and range. So if we're going to say the domain and range for these things, that means that we're going to tell people what are the range of possible inputs and what are the range of possible outputs here. So let's take a look. With this one, our inputs start over here at -3 and they increase. X can go to infinity along this line. Okay, so we have values of X that are all real numbers. So we would say X is of the reals. All right, put these in squiggle brackets, curly brackets, they're called. And I like putting a line there to divide this statement from another statement and saying -3, always start from the smallest, is less than X values, and the squiggle bracket. In this case, the open dot tells me to exclude that value from the domain and range. Okay, it's not included. It's not a possible value for the function. But it starts immediately after that and then continues along. Okay. Y, on the other hand, Y is also real numbers. How do I know it's real numbers, Mr. Jennings? A good question. I'm glad you asked. Because this is a continuous line, it indicates that all of the points in between the integer values are included. Okay, that's a solid line, means include those values. Okay, so Y is also of the real numbers. And then we're looking at range. So we're saying, what are my possible outputs? I see my lowest output is down there at -2. and then they grow and get bigger and go off to infinity this way. So we would have minus 2 is less than, but also equal to y. Okay, so y also equal to, because y can be, it can be as small as minus 2. X cannot be minus 3 because that was an open dot. So that's why I use less than 3 there. Or negative 3 is less than x, and negative 2 is less than or equal to y. Okay. With this one here, it goes off to infinity that way and off to infinity that way. So we would just say x is real numbers and y is real numbers, and we put them all in curly brackets.
Curly brackets.
Wacky curly brackets.
Wacky curly brackets.
If we have a situation like this where we just have a collection of points, they're all integers, we might specify to our reader that x is actually integer values, not numbers in between 0 and 1 or in between 1 and 2, just the positive and negative counting numbers, including 0. And then we have a small list of numbers, so we just list them from smallest to largest. If you have any repeats, you don't need to repeat them. So x is of the integers, and x is minus 1, comma, 0, comma, 1, comma, 2, done. Okay, y is also of the integers, and y is 0, comma, 1, comma, 3, comma, 5, comma, 6, done. All right, this one here, well, I didn't show you a table of values. I didn't show you a graph, but I expect that you can recognize that the vertex is given by this number, positive 2, not negative, and this number, negative 5. So that's the vertex down there. You visualize that it's a parabola that opens upwards, and then you'll know, well, okay, x can be any number. I can have x negative infinity, positive infinity, no problem. But y is definitely going to be minus 5 or greater, because that's the point 2, negative 5. Okay, so we would say y is of the reals, and negative 5 is less than or equal to y. Done. And what about x? Well, you just say x is real numbers. Done. Okay, so that's question types 1 and 2 for the review sheet. I hope that's useful to you. And if you have any questions, hit me up by email or join me in this Google Meet. Bye for now, everyone.